Well, let's try it. I didn't do this one ahead of time. We got K goes from 3 to infinity. And we have 1 over K, ln K, all of that squared. Anybody have a hunch? Why am I asking if we have a hunch, if we have a suspicion of what it will do? It's because that affects the comparison series we choose. If our hunch is that this is going to converge, we're going to choose a series to compare it with that we know converges. If our hunch is that it diverges, then we're going to pick something that we know diverges. That's why I'm asking that. You think it's going to diverge? You think it converges? Okay, do you guys agree that this is the same as 1 over K squared ln K squared?
The whole thing, all the
Now,
whole function.
what do we know about 1 over K squared? Converges by P series, right? If the exponent here is greater than 1, then it converges. If it's less than or equal to 1, it diverges. Okay, so we know that just this would converge, don't we? If we multiply by ln K squared, that simply makes our denominator even larger, which makes the fraction smaller, which makes it even more likely to converge, correct? So, sorry, it's likely gonna converge. That would be our hunch. So, I don't know how this is gonna play out, but I'm gonna go ahead and try using this. Let's see what happens. You like that? Let's try it. So let's go limit as K goes to infinity of our original over 1 over K squared. Multiply by the reciprocal. And these K squareds cancel out. And we have our limit. As K goes to infinity of 1 over ln K squared. What's that limit going to equal? Or what's our denominator going to as K goes to infinity? Infinity. Ln of infinity is infinity. Okay? So that, if you square it, that's just infinity squared, which is infinity. So this is going to equal 0 then, isn't it? 1 over infinity is 0. All right, what does the test say? Get your paper out if you need to. We did the limit comparison test. What does it tell us?
If the limit is greater or equal to 0, then it's converging.
So it says strictly greater than, then they both do the same thing. There's this, what does it say if it equals 0?
That's already converging.
Oh, not here, did in the book. What is
Greater or less, or greater or equal
it? 0.
What test are we on?
That's interesting. The limit comparison is the second test on the last page. The book states it
if it's P less than? No.
So, according to your paper, if this is greater than or equal to 0, it converges. According to the book, that's dependent on this converging. If this one diverged and we got 0, it would be inconclusive according to what I'm seeing in the book here.
What
Does that
test? What test did we use? The comparison?
Limit comparison.
Limit comparison. Okay, thank you.
So, converges by limit comparison test with 1 over k squared. You guys all right with that? Everything we've done so far has applied to, well, not the telescoping series, but these other tests have applied to series that have positive terms, positive decreasing terms, positive non-increasing terms, right? None of these, except for the telescoping and geometric, other than those, none of these have applied to alternating, where we have plus minus, plus minus, plus minus happening. Does that make sense? None of these have applied to that. In section 10.6, we're going to begin looking at the alternating series. And I'm just going to introduce it here today. Probably not going to do a lot of any examples. I'm going to introduce it with the PowerPoint, and then we will take off with it on Monday. This one is actually quite simple. Okay, section 10.6, alternating series. So, if you have an alternating series, here's an example here. That's actually, see it's over K. That's actually the alternating harmonic series. This is like 1 over K, except it's changing sign. And check it out, in alternating form, this dashed line, you know, if you put in 1 for K, you're gonna get negative 1 squared, so that's positive 1 over 1, so you get 1. And if you put in 2 for K, 2 plus 1 is 3, so negative raised to an odd would be negative, so that'd be negative 1/2. Add that to 1 and you get 1/2, so that's 0.5. And then it keeps jumping, we're adding these, they keep jumping up and down. These are the sums. This is the sum of the first 2 terms, sum of the first 3, sum of the first 4. And they keep jumping around this line, and they're gonna get closer and closer to that line. That means they converge. So the harmonic series, 1 over K, in all positive form, which we call absolute form, it diverges. But if you change it to alternating form, you put this little negative 1 to the K plus 1 in here, so it goes plus minus, plus minus, plus minus, then it converges. You see that? Pretty cool, huh? Here's what the alternating series test says. Again, we'll look at examples of this stuff on Monday. The alternating series, negative 1 to the K plus 1, that causes it to alternate sign. Converges provided, listen carefully, there's 2 conditions for it to converge. The terms of the series are non-increasing in magnitude. That means if you do their absolute values, change them to all positive, they have to be non-increasing. They can't be going up, they gotta be going down, all right? Non-increasing in magnitude, a sub k plus 1 is between 0 and a sub k. that means the plus one term is less than the previous term, but it's greater than zero if you do absolute value. For k greater than some index n, so it might start at 3, it might start at 4, it might start somewhere else. And, so that's the first condition, non-increasing, and the limit of a sub k equals 0. Now notice it says limit of a sub k. That does not include the -1 part, that's only this part, a sub k. Does that make sense? So when they say limit of a sub k, they're not talking about alternating, they're just talking about the expression without the alternating part. So that limit has to be 0, and they have to be non-increasing, then it converges. Yeah, that's about all we're gonna talk about here today. Here's this harmonic series again. This is the alternating harmonic series. It converges because if you look at the absolute values, those terms are getting less, right? And the limit of 1 over k goes to 0, doesn't it? So in alternating form, it converges, even though the absolute form diverges. That's really cool. We'll look at that some more on Monday. There's gonna be a remainder thing. This has to do with remainder, I believe. There's gonna be a remainder thing to deal with this as well. But we'll hit all that on Monday, and I'll hit some examples on Monday. I have the assignment posted. Don't worry about doing it. Just get 10-4 and 10-5 finished, all right? Get those finished so that we can start fresh on this. Then we have one more section, 10-7, which is root test and ratio test. Root test and ratio test. And we're gonna see some crazy stuff with that. Not real hard, it's just crazy, all right? Kind of fun. Have a great day. Have a great weekend. 6 weeks.